Good morning, one and all. Myself, Professor R.S. Kognole from Birabai Savan College of Engineering, Nare, Pune. Today, I will be discussing on flow through siphon. So, let us understand what is a siphon first. Siphon is a long bent pipe which is used to carry water from one reservoir to the another reservoir, which is separated by a hill or a higher level ground. The figure shows there are two reservoirs, reservoir A and reservoir B, which is at a different level and connected with a long bent pipe that is nothing but the siphon. Point C is the highest point of the siphon, which is called as summit point. The pressure at point C is less than the atmospheric pressure as it lies above the free water surface in the tank. Pressure at C can be reduced theoretically to minus 10.3 meters of water column, but in actual practice it's only minus 7.6 meters of water column. So to understand the siphon, let us see the schematic diagram of this siphon and let's see the working of this siphon. The figure shows reservoir A and reservoir B connected with a siphon. The negative pressure or the vacuum pressure is created in this siphon so that the liquid gets pushed through the pipe. The flow through the siphon remains continuous till the pressure in the siphon pipe remains negative. The pressure can be determined by applying the Bernoulli's theorem. So, with the help of Bernoulli's theorem, we are going to determine two parameters, that is the head loss in reservoir A and B, and second is the pressure at point C. So, applying Bernoulli's equation in reservoir A and reservoir B will give us what is the head loss. So if we apply the Bernoulli's equation at these two sections, pressure at A and pressure at B being atmospheric, it's going to be equal to 0. Velocity in reservoir A and velocity in reservoir B is going to be equal to 0, and the datum heads between the reservoir A and reservoir B will give us what is the head loss. Head loss can be represented by H, and head loss is going to be equal to the loss due to entry. Next is going to be the flow through the pipe, that is the frictional loss, and next head loss due to exit, that is head loss is equal to major loss plus minor loss. Major loss is due to friction and minor loss is going to be due to entry and exit. If we write the equation as studied previously, the equation what we are going to get for head loss is going to be equal to V square by 2G in bracket 1 plus 1.5 plus FL divided by D, where V is the velocity of the pipe and L is the length of the pipe, D is the diameter of the pipe, and F is the friction factor of the pipe. Next, to determine the pressure at the summit point, we need to apply Bernoulli's equation between section A and section C, that is at the reservoir level and at the summit level. So, if we apply Bernoulli's equation at A and C, pressure at A is equal to 0, velocity at A is equal to 0, and velocity at summit, that is Vc, will be represented as velocity V. So Vc is equal to V, which is velocity to be determined. So head loss at in between A and C is going to be due to entry and friction. So if we write the equation for entry, it is going to be 0.5 V square by 2G, and for friction it is going to be FL V square by 2GD, and we substitute the values for it. Whatever equation we are going to get is going to be H max is equal to PA by gamma, which is equal to 0. So that term is going to be cancelled out, which is 0 minus PS by gamma. PS by gamma is nothing but pressure head at summit point, which is to be determined, minus V square by 2G in bracket 1.5 plus FL divided by D. So from this equation we can determine what is the maximum pressure head at C, that is PS by gamma, where H max is nothing but the height of the summit above the surface in the higher level of the reservoir, that is at C. So distance between the height between the reservoir level and the summit is nothing but the H max. Hope students you all have understood the concept of siphon. Thank you.